Hello everyone, and welcome to the recursion interview solution to the Fibonacci sequence interview problem. Alright, before we get started, just again, a reminder as always, there's a full solution notebook for this interview question in the recursion problems folder. It's the recursion problems-solutions folder here. So this is the notebook. It has the solutions for all three of them, all three requests, and the test your solutions cell. Alright. So let's go ahead and begin. What I'm going to do is go through the problem statement, make sure we understand it, and then do a walkthrough of the three separate solutions for this problem. Now, the question itself was implement a Fibonacci sequence in three different ways. Using recursion, using dynamic programming, so using memoization to store the results, and then using just a straight iterative approach. So remember, just a reminder, the Fibonacci sequence, there's a link here to the Wikipedia article, is just when you take the two previous numbers and add them to get your next number in that sequence. Now, remember the base case checks to see if there's a 0 or a 1. In that case, it returns a 1. Otherwise, it returns this, fib n minus 1 plus fib n plus 2. So in this specific case, what I wanted you to do was for the n that was input, you would return the nth number in the Fibonacci sequence. All right, so let's go ahead and get started. What I'm going to do is start by going over the iterative solution first. So if you scroll down to the bottom of the notebook, that's this one. After that, we'll go through the recursion solution and then the dynamic programming solution. So what we're going to do is first walk through the iterative solution, since that's the most straightforward one. And it also shows that as far as approaches to a particular problem, you don't always have to do it a classic way or a certain way. There's multiple ways to solve a single problem, and that's really the main point of this interview question, is to show three separate approaches to solving a problem. So in an interview scenario, you could easily get asked this problem of a Fibonacci sequence, and you could also be asked to solve it every single way here. So let's start off with the iterative solution. So we'll call this fib underscore iter. It takes an input n. And we're going to go ahead and set a starting point. In this case, we started at 0. I'll say a equals 0, b equals 0. And then after that, all we have to do is just follow the algorithm that's in place. So for I in range, remember we're going all the way to n since we want the nth number. And in this case, we can actually use the tuple unpacking method in Python. I can simply say AB is then equal to B, A plus B. And then I just have to return A. And let me fix something real quick. This should be a 1. And if we actually want to use tuple unpacking further, I can say A, B equals 0, comma 1. And that will assign things. This is using a very Pythonic solution to say A equals 0 and B equals 1. All right. So let's quickly review what's going on here. If I go ahead and run that cell and then input fib underscore iter, put in 10, I get in return 55. Okay. So all this is doing is just saying A is going to be equal to B and B is going to be equal to A plus B. And at the end, return A. So this is just using just a very simple looping technique, using a for loop here to loop through the range, and then using tuple unpacking to set the new Fibonacci number at the n. All right, so that's the most straightforward solution. What I wanted to make you aware of is this nice little link, and I'll add it to the solution notebook. But if you actually just Google Python or 5 ways of Fibonacci in Python, here's the complete URL. It's on TechnoBeans. But if you Google 5 ways of Fibonacci in Python, we can go ahead and do a Google search for that. That will take you to this page, this TechnoBeans page, and it'll show you 5 different ways of calculating the Fibonacci sequence in Python. So you can use that looping technique. This is actually what we just did. In his case, he started at 1, 1. Let's go ahead and zoom in here so you can see better. You can also use recursion, which we're about to go over. You can do it using generators, which is an interesting way. And then you can use memoization, which we'll also go over. And finally, he shows using memoization as a decorator, which we actually go over in the memoization lecture itself for the factorial problem. All right, jumping back to the solutions, we can now go ahead and tackle the recursive version of this problem. So, how will we do this recursively? Let's go ahead and get started. We'll call our solution fib underscore rec. And what we need to do is have a base case and a recursive case. So, what is our base case? Well, we know we need to start with either 0 or 1. And in that case, we can just say if n is equal to 0, or if n is equal to 1, return n. And that's it for our base case, which makes sense because that's how the Fibonacci sequence starts. What about the recursion case? Well, that's actually just writing the algorithm for the Fibonacci sequence. All we have to do is return the recursive call of our function on n minus 1 plus the recursive call of our function on n minus 2. And let's make sure that worked. Going to call it on 10. And there we get 55 out. So what might be interesting to explore is using timeit or any other sort of timing library in Python to see which one of these solutions runs faster. Again, for iteration, all we're doing is setting a equal to 0, b equal to 0, and then for I in range all the way up to n, you're just setting a equal to b and then b equals a plus b. Very similar here, except using recursion, you set your base case first, and then in the recursive case, you recursively call this function on n minus 1 and n minus 2, so those previous two numbers. Then you add them up, that gets you your final solution there. All right. Finally, we want to explore dynamic programming using memoization. So in the form I'm about to implement it here, I'm going to set the cache beforehand, and it's based on the desired n of the number of the Fibonacci sequence. So this is only going to work for this specific n that I know beforehand, so just keep that in mind. All right, let's go ahead and get started. It's going to look pretty similar to the recursion problem we already have, but it's going to be a lot more efficient because we're storing stuff or previous known results in memory. So let's go ahead and get started. I'm going to go ahead and start with the cache information. Now, the particular way I'm doing it now is I'm setting it on an n that I already know I'm going to ask for it. And there's quite a few notes on why I'm doing this in the solution notebook itself and how that affects your test cell in that notebook. So make sure you go ahead and review that before continuing on. And I'll set my cache equal to a list of nones, length of n plus 1 or 11. So I'll multiply it by that. Okay. And then what I'll have to do three things here. I'll have to figure out what my base case is. I'll have to check my cache. And I'll have to basically keep setting that cache. And then finally, what I'm going to do is, since I'm using memoization, is return that nth number on that cache. Okay, so we got three cases here. Let's go ahead and get started. Base case, that's going to be the same as the normal recursion problem. I'm going to say if n is equal to 0, or if n is equal to 1, just return n. So that's pretty straightforward. Those are the first numbers in the Fibonacci sequence. Now, checking the cache. So I know that if my cache at that particular n is not equal to none, all I have to do is return that cache, because it means I haven't filled it out yet, or I haven't set it. And finally, how am I going to set that cache? So that cache of n here is just going to be equal to the recursive call. which is the exact same thing we just did in the recursive solution. So basically, all I'm doing here is the recursive case, but I'm making sure to check my cache first, and instead of just producing these in a recursive fashion, I'm actually keeping track of them by adding them to this list. And in this case, instead of using append, I've set my cache first. I already know what n I'm going to ask for. So if I run this and then say fib DOIN for dynamic and ask 10, I'm going to get 55 out. Now what happens if I choose another n? I will get an error, because you'll notice I get an index error because the list index is out of range. And that's because the way I've set it up here, to make it really obvious that we're having a cache, I set the cache instantiation outside. I would have to set this n value to whatever n I'm going to run first. 144 in this case, for 12. All right, so how could you fix that? Well, you would fix that by using append here and being able to create that cache on the fly as you go along. You wouldn't reset it or set it since the beginning here. All right, so those are the solutions for all three of them. You'll notice that actual coding is very simple. It's the thinking that's the most difficult part of this problem. And that's the case for a lot of these recursion problems. Thinking about the problem is much, much harder than the actual code you're going to write. So let's go ahead and jump to the solutions notebook and make sure we really understand everything we just went over. So the iterative solution, we set a starting point, in this case a equals 0, b equals 0, and we just follow the Fibonacci algorithm. We set a equal to b, and then b is equal to a plus b. Notice with tuple unpacking, I can save myself a temporary variable. So I'm actually not setting a equal to b first, otherwise this would just be b plus b. So that's a really nice Pythonic solution here as far as setting this all in one line. This basically automatically takes care of the ordering, so you don't have any errors of setting b equal to b plus b or setting a equal to the new b instead of the old b. All right. And then for the recursive solution, all you have to do is think about the base case and then just follow the formula or the algorithm by calling it recursively on n-1 and n-2, since you're concerned with the last two numbers of that sequence in order to come up with the next number of the sequence. And in a really similar fashion here, and I've instantiated the cache information first, just so it looks really similar to the recursion solution, we check for that base case, and we set a cache by calling that recursion function if it equals none. All right, so make sure you go ahead and walk through this entire solutions notebook to get a really good understanding of the Fibonacci sequence problem. It's a pretty common interview problem, at least on the basic level, and you can learn a lot, especially on learning how to solve a single problem in a bunch of different ways. And I encourage you as a homework assignment to use some sort of time it feature in Python or some sort of time it library in order to see which one of these runs the fastest. Okay, so that's it for this interview problem. Good job, everyone, and I will see you at the next lecture.